Okay, so this is uh, chapter 1 of our syllabus under Math 34, Engineering Calculus 1. And chapter 1, I will divide this one into two parts or two videos. So this will be the first part. And chapter 1 is about first, we will define a function. What's a function? What's the definition of a function? Then next, we will try to classify enumerate the different classification of the functions. And after knowing those classifications, we will also try to solve the domain and range of a function. Then we will try to graph them also and some functional notation. Then the part 2 will be about the evaluation of a function, how do we combine functions and compose functions, one valued and many valued functions, odd and even functions, and other special types of functions. So after chapter 1, you should understand the basic of a function. You can define a function. You can classify them on what types of functions are you dealing with. And also you can identify the domain and range of a given function. You also need to know that after the chapter 1, you should be able to sketch up the graph functions and determine if what special type of a function is in the problem. So let's start with the definition of the functions. So what's a function? Basically, function is defined as this is uh, some expression where where each input and this input is usually denoted by the letter x has exactly one output or result. Which you usually denote with the letter y. So a function is some expression where each input x has exactly one output y. So input means this is the stimulus. This is our uh, value for x, and the output will be the result of that input with a certain expression. And usually we use f of x to denote a function f of x. We denote it as f of x or g of x and so on. And in differential calculus, we will be uh, usually using f of x, or sometimes we can also use instead of f of x. This is also the same as y. That's the output, or f of x function. This is read as the function of x. So it can be any expression that if I input a value of x, then it should have just one result or one output y. So that's the basic definition of a function. And how do we determine if a certain expression is a function? So if I have here uh, a expression y is equal to 2x plus 2. Is this a function? Yes, it's a function. Why? Because if we apply a value for our x, we only have one result for y. An example of a not function expression is if we have y squared equals 2x plus 2. So this one will result to a 2 output with 1 input. Why? Because if you take the value of y here, y will be the square root of 2x plus 2, and it should be plus and minus. So this means that if you apply an input of x, your result will always be a plus and a minus. So there are two outputs. So if there are two outputs, now you violate the definition of a function, which is it should has exactly one output only. So this one now cannot be considered. This is not a function. Another way of determining if a function or expression is a function or not is we have what we call the vertical line test. Vertical line test. What is this? So if you have the graph of that expression, you just need to draw a vertical line that will connect the, for example, if we have here a certain function. So if this is the function, let's say this is the function. Now if you draw a vertical line, let's make it red. So at every point of uh, this function, it only crosses the, the plot one time. So this means that this function can now be considered, this expression can be considered a function. So this is a function. So another example is if we have this one. So if this is your f of x, this is your function f of x. Now if you apply a vertical line test to determine this one if it's a function or not. So if I draw a vertical line, then that vertical line will intersect f of x twice, here and here. So this means that this expression f of x here cannot be, it's not a function. It's not a function. So that's vertical line test. You just draw a vertical line, and if the vertical line intersect the plot more than one, two or more, then that's not a function. But if it intersect one time, then that plot is considered to be a function. So that's a function. Now let's try to discuss the different classifications of a functions. So what are the different classifications or types of functions? Classification. So the first one is, we call it, this is the very basic classification, algebraic functions. Algebraic functions, these are functions that involves algebraic operations like addition, subtraction, multiplication, and division. And generally, we can divide algebraic functions into also different categories. So we have first is, we call it a polynomial function. Polynomial. So a polynomial functions, this is in the form, so usually we denote this one as p of x. So this means this is a function that's a polynomial, and this is denoted in the form of this one, a n or a0, a0, or any variable x raised to n, then plus a1 x raised to n minus 1 plus dot 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 plus up to uh, a a's of n up to the constant a's of n. So this is a general form of a polynomial, and we can also divide a polynomial functions into different categories using this general form. So we have the first one, we call it a linear function, linear polynomial function. Uh, this one, when the polynomial has a degree equal to 1. If the degree of the polynomial is 1, we call it a linear function. So example of a linear functions are y equals 3x plus 2, uh, 2x plus 3y equals 5. So these are linear functions when the degree is just equal to 1. The next one is, if the degree is equal to 2, we call it a quadratic function. Quadratic. This is when the degree is 2. So if the degree is 2, we call it a quadratic function. So example is y is equal to x squared plus 3x plus 5. So you know how to determine the degree of a polynomial. You just look at the highest exponent, then that will be its degree. Then if we go higher, the next one is if the degree is equal to 3, we call it cubic function. Degree is 3. So example, y equals x cubed plus x squared to x squared plus 5x minus 1. And if it's equal to 4, we call it quartic function. Quintic function and so on. So this one, a degree is 4. Y equals 4x to the 4th plus 5x cubed plus 6x squared minus 2x plus 1. And if we go a little higher, 4, the next one will be raised to 5. We call it the quintic function. So this is the degree is 5. So 5 equals x raised to 5 plus 2x squared minus 3. So that's a polynomial function. So it can be categorized using the degree of that polynomial. So it can be linear, it can be quadratic, cubic, or quartic, or quintic. Then after polynomial, still under algebraic functions, we have, so letter B, we have rational functions. Rational functions, these are composed of polynomial functions, but it's a ratio between two polynomial functions, and usually we denote this one as f of x equals, we have the numerator and the denominator. The numerator is a polynomial, the denominator is also a polynomial functions. So example is f of x equals 2x squared plus 3x plus 5 divided by 2x plus 3. So this is a rational function. And there are also different type of rational functions. We have proper and improper. Proper when the degree is greater than the degree of the numerator is less than the degree of the denominator. Improper if the degree of the numerator is greater than the degree of the denominator. So we can apply synthetic division first to simplify a rational function before we deal with those type of functions. So that's rational functions. And we also have, if there's a rational, there's also irrational. Irrational, or this is what we call the radical functions. It's also called the radical. Why? Because these functions are functions that contains a radical. It's also a polynomial functions, but it only contains radical signs. And this is in the form, so f of x is the nth root of any polynomial function. So for example, if f of x or y is equal to the cube root of 3x squared plus 2x plus 1. So this function can be considered a radical function under algebraic functions. So these are the different types of algebraic functions that we will be dealing under differential calculus. So next, we also need to discuss the next one. We call it the transcendental functions. Transcendental functions. So what's a transcendental functions? Transcendental functions, these are functions that are not classified as algebraic functions. And usually, these are trigonometric functions, exponential, logarithmic, inverse, hyperbolic, and so on. Those are considered transcendental. So if we have first the most common transcendental functions is the trigonometric functions. So what are these trigonometric functions? Basically, trigonometric functions are functions that involves sine, cosine, tangent, and the different identities in trigonometry. So sine is equal to 1 over cosine, cosine is equal to 1 over sine is equal to 1 over cosecant, cosine is equal to 1 over secant, and tangent is equal to 1 over cotangent. Those are trigonometric identities. And if your functions has these operations, then that is considered to be a trigonometric function. So for example, if f of theta, usually we use theta when we are in trigonometric functions, f of theta is equal to sine 2 theta plus cosine squared theta. So this can be considered to be a transcendental under trigonometric functions. And we also have exponential functions, exponential functions. So exponential functions, these are functions that involves exponents. So for example, uh, y is equal to e raised to x. So this is the basic exponential function. If we have e, then that's an exponential function. Then the opposite of exponential function, or the inverse of exponential function, we call it the logarithmic functions. By the way, this function here, this exponential function, it can be in the form of e raised to any polynomial, raised to any polynomial, or you can multiply it with any polynomial. And for logarithmic function, so this is the inverse of the exponential function. Uh, Another form, before we talk about logarithmic, I forgot the another form for a logarithmic function, a exponential function. It's not only uh, e, but sometimes it's also in the form f of x is equal to a constant raised to a polynomial. So e is a constant, so it's not just limited to the value for e. It can be any constant that is raised to an exponent of a polynomial or any type of other functions, where b is a constant. So this is a constant, it's just a number. So the example is e raised to x. E is a constant. Now, for the inverse of exponential, which is the logarithmic function, logarithmic function. So these are functions that contains logarithm or log, and this is actually the inverse of exponential. Later on, I will discuss why it's the inverse. A logarithmic function is in the form f of x equals the logarithm to the base b, any base of a certain polynomial. So we read this one as the logarithm of p of x to the base b. So this is the general form of a logarithmic, and if it's b is equal to, there are some properties for logarithm. So why does it is defined as the opposite or inverse of exponential? Because of these some properties. So let us look at some properties of logs. So this is just a review of your pre-calculus or algebra. So 1, y is equal to log b of x. This is equivalent to b raised to y equals x. This is equivalent to b raised to y equals x. This is the reason why the exponential functions are the inverse of logarithmic functions. Because if you take, for example, let's first discuss the different properties before we talk about that one. So another one is when this is equal to 1, any base b, this is equal to 0. These are some properties. Log of, right, b to the base b. If the base is equal to this one, then this is equal to 1. And if you don't see any base, this means that that is to the base 10. And also if your base, this one, if your base is equal to e, a constant e, then this is what we call the natural logarithm or the Napier logarithm, ln of x. And if you have a product, the log of a product of two functions, log of f of x times g of x, this is equal to log of f of x to the base b plus log of g of x to the base b. If it's division, log of b of f of x divided by g of x, then this will be equal to log of f of x to the base b minus log of g of x to the base b. Then what else? We also have some other properties, advanced properties, logarithmic of x raised to r, or let's just make it x with exponent r, constant r, to the base b. This can be simplified as r log of x to the base b. Then the relationship between the logarithm and exponential functions is, so we know that f of x in exponential, f of x is equal to b raised to p of x. Now if you take the natural logarithm at both sides of this function, ln of f of x will be equal to p of x ln of b. So the exponent or the exponential function becomes a logarithmic function, and it cancels out the exponent. And if you raise this one with e, you can also go back to the exponential function. So if you raise this one to e at both sides, then this will be equal to f of x will be equal to e raised to p of x times ln of b, which is just a constant. So you go back to the exponential. That's why it's the inverse. Exponential is the inverse of logarithmic. So that's exponential and logarithm. Another type under transcendental, under trigonometric, are inverse trigonometric functions. So what are these inverse trigonometric functions? It's just the inverse of trigo. So if the function involves sine inverse raised to -1 of theta, so this is inverse. Now take note, the sine inverse of theta, this is not equal to 1 over sine theta. Remember this one. This is not equal to 1 over sine theta. And that is also true the cosine inverse theta is not also equal to 1 over cosine theta. Tangent inverse theta is also not equal to 1 over tangent. Another notation for inverse trigo, they use arc. So this means sine inverse theta is the same as arc sine theta. Cosine inverse theta is equal to arc cosine theta. Tangent inverse is equal to arctan. So it's the same, sine inverse or arcsine. So it's better to use arc so that you cannot you can tell that it's not equal to 1 over sine theta. It's arc. So it will be never be equal to 1 over sine theta. So that's inverse trigonometric. We also have the hyperbolic function, hyperbolic trigonometric function. So these are still uses sine and cosine. So what is hyperbolic? So we denote them as sine hyperbolic of theta. So there's an h, cosine hyperbolic theta, tangent hyperbolic theta. So if you see letter h between cosine and theta, that means that it's an hyperbolic function. Then we can also have inversed for hyperbolic. We can so take the inverse of that one. Sine h raised to negative 1 theta cosine h inverse theta tangent. But take note, it's not because you're using sine, cosine, tangent. Not all, remember this one, take note, not all the uh, identities in a normal trigonometry functions or identities is not applicable in hyperbolic functions. Not all. For example, sine squared plus cosine squared. The in trigonometry, sine squared theta plus cosine squared theta is equal to 1. In hyperbolic, this is not true. Sine hyperbolic squared theta plus cosine hyperbolic squared theta is not equal to 1. Later on, we will discuss more about hyperbolic functions when we take the derivative of this type of functions. But remember, this is not always true. The trigonometric identities uh, cannot be always true to hyperbolic functions. Some can be applicable, but not all. So those are the basic classifications of functions. Later on, we will discuss more about functions, those special type, the odd and even functions, the piecewise functions, constant functions, and so on. And before we go to those functions, first, uh, we will be discussing about the domain and range of these functions. So domain and range. So how do we determine or identify the domain and the range of a function? So before we identify them, first we define what's a domain. What's the domain of a function? The domain of a function is or the possible values of its input. The possible values of its input x. So all the possible values, we call them the domain of that functions. And the range is the result, the, the possible result the possible result of the domain. So that's range and that's domain. Now, how do we determine the domain and range? Basically, there are two reasons why the domain, first the domain, we calculate the domain. The domain are restricted. Those reasons are, first, if the denominator is equal to 0. 0 denominator. And another restriction is when a radical, there's a negative inside a radical with even index. So generally, the functions that has restriction of its domain, or when the function contains a denominator, so that will be a rational function. Number one will be a rational function. If you have a rational function, the denominator cannot be equal to 0. And for number two, this is a radical or irrational function. So these are the basic two functions that has restriction of its domain. So if the function is just a simple polynomial, then the domain and range or the domain is not restricted. And for the range, it can be identified or determined graphically or algebraically by simply solving the domain of the inverse of that function. So let's take an example. So example, determine the domain and range of y is equal to x squared minus 4x plus 5. So what is the domain and range of this function? So solution. So for the domain, what is the domain of this function? So first, let us look at what type of function is this function. It's a polynomial, a quadratic polynomial function, and it's not rational. It's not irrational. So we can now conclude that this function has no restriction to its domain. So we can say that the possible values for the input x are all real numbers. So this means x can be all real numbers. The domain are all real numbers. Another way to write the domain is through this notation from negative infinity to positive infinity. So this quantity here, when you writing the domain in this form, the quantity means uh, infinity is not included to the range or the domain because there's no such thing as infinity. So this only means that the domain is in between negative infinity up to infinity. If you include a certain number to the range, you use bracket. Bracket, this means included. If it's a parenthesis, then not included. Another way is through greater than or equal notation. So x is greater than negative infinity but less than positive infinity. So these three are all the same, or you can simply write the domain are all real numbers. These are different ways in writing the domain. So you can use the first one, you can use the second one, or you can use the third one, or you can just write word by word. Now, for the range, how do we determine the range? It's not because the domain are all real numbers, then it's automatic that our range will be all uh, real numbers also. It's not true. So how do we determine? So we will be using algebraic manipulation, and what we do is we take the inverse of that function. How do we take the inverse? We just interchange y and x. So how do you do that? So y equals x squared minus 4x plus 5. So we need to make x to be on the left side. So we will be actually solving the function of y. Function of y. So this will be x. Then if we can determine this one, then the domain of this will be our range. will be our range in the actual problem. Then the question is, how do we do this one? How do we take the inverse? So to do that, we need to interchange first. So we do algebraic manipulation for x. Then I will put here y minus 5. So I make this one negative 5. I put 5 to the other side. Then what I do is I want to complete the square. So how do we complete the square? We make this one a perfect trinomial. So to complete the square, you need to take the coefficient of the middle term. So we need to take the coefficient of the middle term, which is 4. You divide it by 2, then you square it. So that's completing the square. But remember, what you add to the left side, you need to add it again to the right side of the equation to make it to neutralize the equation. So 4 over 2 squared. What is 4 over 2? That's 2 squared. Then you can factor out this one, this part, and this is just equal to x minus 4 divided by 2. That's 2, and we just square this one. And that will be the factor of x squared minus 4x plus 2 squared. And this should be equal to y minus 5 plus 4. So negative 5 plus 4 is negative 1. So minus 1. So we didn't change the function. We only manipulate the function. Then I want x to be alone on the left side. So we need to take the square root. So x minus 2 is equal to the square root of y minus 1. Then x is equal to the square root of y minus 1 plus 2. Then question is, what is the domain of this function? So the domain of this function now, as the domain here, we have a radical, square root of y minus 1. So if there's a radical, is a rational function, then there's a restriction for the domain. So this radical y minus 1, this should not be uh, less than 0 or negative. So it cannot be negative, so it should not be less than 0. Otherwise, if it's less than 0, then what happens is the restriction of the domain. Or it's the other way around. It cannot be less than, so it should be greater than 0 or equal to. 0 can be included because the square root of 0 is 0. Then to solve this one, we square both sides. Then we have y minus 1 is greater than or equal to 0, or y should be greater than or equal to 1. So this will be our range. So our range now will be y should be greater than or equal to 1. Or we can use the other notation, this one, from 1 up to positive infinity, but not included yung infinity. So take note, I use bracket. Why did I use bracket? Because 1 is included. It can be equal to 1. If it's equal to 1, y minus 1 is equal to 0. Square root of 0 is still possible. So this will be our range. The range are all numbers that are greater than or equal to 1. Another way to determine the range is through graphical method. You can graph or plot the function Then if you try to plot this function y equals 2x squared minus 4x plus 5, this is a parabolic function. It's a quadratic, so the graph is parabola. Then this is the graph. So this will be the result of the graph. So graphically, we can determine the range. So the domain, it's obvious that from positive infinity to the negative infinity, it's all possible. But the range, it will not, the plot will not go below 1. So it's true that the range should be greater than or equal to 1. So this is the range from 1, then it goes upward. So the plot will not go less than 1. So that's another way of determining the, the range of a certain function. Let's take another example. Before we end this part, let's take more example of determining the domain and range. So A, determine the domain and range of a f of x equals x cubed. So this is a cubic function. So what will be the domain? It's not radical, it's not quadratic. So the domain is all real numbers. So x is all real numbers. The range, how do you solve for the range? So we can take the inverse of this one. So what will be the inverse? So f of y, so this is equal to y. F of y will be equal to the cube root of x. Now, this is a radical or irrational function, but take note that the index is 3. So it's an odd index. So remember our condition in the domain here, negative inside a radical with even index. So this means that this is not a restriction. So what are the possible values? It can be any number, any real number. So the range here will be y, all real numbers. Another example, so letter P. If f of x is equal to 1 over x minus 4 times x minus 1. So what's the domain? So for the domain, this is a rational function because it has a numerator and denominator. So it can be restricted. So what we do is we take the denominator, which is x minus 4, x minus 1, and this should not be equal to 0. So this can't be equal to 0. Otherwise, that's a restriction. It's not part of the domain. So when will this polynomial x minus 4 times x minus 1 be equal to 0? So let's try to solve that one. That will be now x minus 4 equals 0 and x minus 1 equals 0. So x should not be equal to 4 and x should also not be equal to positive 1. So x is not equal to 4, x is not equal to positive 1. So what will be our domain? So our domain now is it cannot be equal to 4 and 1. So we can write this one as x from negative infinity then less than 4, or let's take 1 first. It cannot be equal to 1. So 1, but 1 is not included, so I will be using a quantity. 1 is not included. Why? Because it cannot be equal to 1, so we use quantity here. So from negative infinity up to less than 1, then we used union. So this is a set. Union means it's included to the set. Then after that is from 1, but 1 is not included, up to 4, and also 4 is not included. Then union again from 4 not included, up to positive infinity. So this is a fancy way of writing the domain. The more simpler way is to just tell it the domain are all the real numbers except 1 and 4. So except 1 and 4. So this is a simpler way of writing the domain. How about for the range? So it cannot be equal to 1 and 4. So for the range, and again we can use or calculate the range algebraically by, just like we did before, we used completing the square. So for the range, so to solve for the range, we go back again to the function 1 over x minus 4 times x minus 1. So f of x, we just make that one to be f of y. It should be f of y, or we can solve for x. So to do that, we need to solve for x, and to do that, let's just rename the function to be equal to y. So y is equal to 1 over x minus 4 times x minus 1. So let us rearrange this one. Let's make it f of y. So we need first to simplify. So we multiply the denominator. X squared, x times x squared, x times negative 1, negative x, negative 4 times negative x, negative 4x, plus negative 4 times negative 1, plus 4. Then simplify further. This is 1 over x squared minus 5x plus 4. And again, we do completing the square. So y will be equal to 1 all over x squared. So what's the middle term? It's 5. So we take the middle term, we divide it by 2, and we square that one. So that's the completing square. And plus 4. Then we add 5 over 2 squared. So we need to subtract it to retain the equation 5 over 2 squared. So it will just cancel out, but we don't need to cancel that out because we need to factor out this one. This is now a perfect trinomial here. So this will be 1 over x minus 5 over 2 square. Then if we simplify 4 minus 5 over 2 squared. So 5 over 2 is 2.5. You square that one, it's 6.25. Then 4 minus 6.25, that will be negative 2.25, or that's negative 9 over 4. So it should be minus 9 over 4. Then we do cross multiplication. X minus 5 over 2 squared minus 9 over 4, and this is equal to 1 over y. Then next is we put 9 over 9 to the right side because we want to solve for x. So x minus 5 over 2 square is equal to 1 over 9 y plus 9 over 4. Square root both sides. X minus 5 over 2 equals the square root of 1 over y plus 9 over 4. Then solving for x, x will be equal to the square root of 1 over y plus 9 over 4 and plus 5 over 2. Then let us solve the domain now of this function. And again, we have here a radical sign, so the restriction is it should be greater than or equal to 0. There should not be a negative inside the radical. So 1 over y plus 9 over 4, this should be greater than or equal to 0. And 1 over y should be greater than or equal to negative 9 over 4. And to calculate the possible values for y, you can use the number line if you remember how to solve inequalities. So this is one way of solving inequalities. You take a number line, you make the center to be 0, here to the right side, to the left side positive, to the right side, to the left side negative, to the right side positive. So 1, 2, 3, 4. Negative 1, negative 2, negative 3. So let's first take uh, from the right side. So let's take any value from the right side. Let's say I choose 2. So if y is equal to 2, then this term will be 1 over 2, 1 half. 1 half, yeah, it's greater than negative 9 over 4. We take 3, 1 over 3 is still greater than negative 9 over 4. We take greater than 4, it's always uh, satisfy the condition that is greater than negative 9, 4. Even if we take 1, even if we take less than 1.1, but if we take 0, this is 1 over 0. So, therefore, we can conclude that 0 is not part of the solution. So, we encircle that one. And all the values to the right side up to positive infinity here, all the values here up to positive infinity are part of the solution. So we check already the right side, we check 0. 0 should not be part of the solution because it's over 0. Then we check the left side. So for the left side, because this is negative 9 over 4, so if we solve for y here, if we do cross multiply, so 4 over 9, so this is negative 4 over 9, should be greater than or equal to y, or this is y should be less than or equal to negative 4 over 9. So this means that the only possible values for y are from negative 4, 9, and less than negative 4 over 9. Negative 4 over 9 is around 0.44, so somewhere here. So this is 4 over negative 4 over 9, negative 4 over 9. Then the solution is from this is included, so this should be a solid circle. Then all the values here are also part of the solution. So if we write now our final value of our range, so our range now will be, so from negative, or we start with the positive 0, but 0 is not included, so it's a quantity, it's a parenthesis, from 0 up to positive infinity, and also positive infinity is not included, and we take the union of this set to the negative one, from negative infinity up to negative 4 over 9, but 4 over 9 should be included, so this should be uh, a bracket, so this will be our range. So, or another way is x is can be greater than 0, but less than or equal to negative 4 over 9. So x is greater than 0 and less than negative 4 over 9. So this will be our range, the value of range. Okay, so that is domain and range. So take note, to solve for the domain, look for the restriction. What are the restrictions? Restrictions are, first is if there is a rational function. Then the second one is if it's irrational that has an index equal to or even index. Odd index uh, are not restricted, only even index that are irrational functions. So this last example, you can also do solve it graphically, and the graph will be this one. So if you look at the graph, if we look at our graph, so this is x equals 1 and x equals 4. So it will never cross x equals 1. This is our function here and here and here. It will never cross x equals 1. It's we call this one the asymptote. Asymptote. This is also an asymptote. So in chapter 2, that we will be discussing chapter 2, those are types of discontinuity, asymptotes and poles. So it will never meet the x equals 1 and x equals 4. So that's the restriction for the domain. And for the range, so it will also not meet 0. This one here will go through negative infinity, but it will never reach the value of y to be 0, and also here it goes to positive infinity, and it will never intersect with the x-axis. So it will never reach a 0 value for our y. And here, so if we project this one, this is around or more or less uh, 0.5 or less than 0.5. So it's 4 over 9, it's around 0.4. And that's actually what we have solved here for negative 4 over 9. It should be less than or equal to negative 4 over 9, and so on. So the range will be from here, you go downward up to negative infinity, but then from 0 here up to positive infinity, but 0 should not be included here. 4 over 9, negative 4 over 9 should be included, but here 0 is not included. So that's domain and range. So if you have any more question about domain range, you can raise your questions. And if you want more examples may also be given through the modules that will be giving you, so you can have more examples to practice on, and also for the problem sets. So that's part 1 of chapter 1.